Yet? Why are people still browsing at breakfast? What's up? My name is Drummond Rennie. Welcome to the 8th Peer Review Congress. It's a day for me. Exactly 50 years ago, September 10th, 1967, having run out of research funds in London, I emigrated to Chicago, and what a wonderful anniversary that was. It's a good omen. Can we have the slide, please? I'd like to begin by honoring I don't usually do this sort of thing, honoring my friend Jean Garfield, who's having dinner there at our house, Deb and mine, age 91. He was a genius, a good friend to me, a generous benefactor to the Cochrane Center in San Francisco. The fundamental reason we undertake peer review is to increase the quality of what we publish, but papers in our field are bedeviled by failure to establish a reliable metric for quality. Looking back, it's clear that everything changed with Jean's article in the late 50s on exactly that. He took a simple idea, the quality of an article, a journal, or a scientist could best be gauged by the use that other experts in the field found when they found them useful enough to cite. And he solved the problem of how many journals by an extension of what's called Bradford's Law. In other words, 20% of whatever contains the gist of 80% of what's done. Jean had a huge vision, a mathematical insight, originality. He made the impact factor metric happen. He had the entrepreneurial talent to make people see his way, and he became rich. For the first several peer review congresses, the impact factor became the defining metric to select journals for study. He showed that quality could be measured, and despite his own stringent warnings against impact factor, its use, its limitations, and misuse, we still depend on Jean's basic metric. Dear Jean, you clever, clever, clever man. What a Pandora's box you opened. Now I'm going to thank everybody who matters, apart from Annette Flanagan, who matters very, very much indeed. Early on, we at JAMA were joined by the BMJ, first Richard Smith and then Fiona and Theo Bloom's here, and Trish and all sorts of BMJ, robust researching people from the BMJ with lots of moral backing. That's proved to be crucial, especially when finances look rocky early on. More recently, we asked the newly formed Meta Research Innovation Center at Stanford, Metrics, in the formidable persons and gigantic brains of Steve Goodman and John Ioannidis. We asked them in. We take reviewing research on review very seriously. Annette Flanagan and I thank our advisory board reviewers for their work on the record 260 abstracts that came in. Annette and I decided the task of handling the abstracts and reviews was altogether too hard for us, so we brought in Mike Berkowitz, who's prowling around. My own email box contained nearly 3,000 emails on my portion alone. Thank you, Mike. Thank you for our sponsors, and their names will appear on slides during the day. Please look at the names, please look at the exhibits. 28 years ago, what we really needed was an energetic support of the visionary George Lundberg, then editor-in-chief. We've always had consistent backing from the AMA, most recently in the person of our publisher, Tom Easley. I'm moved to find that right now, our most enthusiastic, wisest, and smartest guide and friend is my old boss, Howard Bauchner, or my young old boss, Howard Bauchner. He's allowed us a free hand. And of course, none of this would have been at all possible without dear Annette. Her brilliant mind, subtle ways, organizational muscle, really. Say hello to her, her staff, Rosa, Jenny, and Caroline, and also to Connie, who works back out with me in Oregon. And as always, I thank for a constant encouragement my dear wife, Deb, whose name, that's Dee Rennie, gets muddled with my own and whose scientific achievements will, I hope, greatly enhance my H factor. Housekeeping. We have a very primitive, old-fashioned format. Everyone can hear everything. Talks will start and stop at the allotted time, and you should turn off your phones, by the way. We strongly encourage you in the audience to ask questions. When you get up and go to the mic. Stand there, you'll be called in order. Speak up, say who you are, ask a question, don't give a speech. All the presentations will be embargoed until 8 a.m. on the day of presentation. So let battle commence, or the games commence. I now introduce our first plenary speaker, Elisa Bero, who's a close colleague and friend, has moved from our place, the University of California, San Francisco, to the University of Sydney. She directs the Evidence, Policy and Influence Collaborative Research Program at the Charles Perkins Center. Her subject is Peer Review, Are We Looking at the Right Things? Lisa.
Thank you. Thank you, Drummond. And as we all know, Drummond is the driving force behind the Peer Review Congress, and so I think it's only fitting to start my talk with a quote from Drummond, and this was in his Nature article introducing this Congress. So Drummond says, rightly, he's advocated for research to improve peer review and thus the quality of the scientific literature. And much of the research presented at the Peer Review Congress has shown that this causal connection suggested here between peer review and quality is really a leap of faith. But that depends on how you define quality. And I define quality as a publication that is not biased in its design, its conduct, or its reporting. So since the start of the Peer Review Congress, it has been contributing immensely to our understanding of the types and sources of bias in the scientific literature. There have been a number of other collaborators on this hunt for bias. For example, the Cochrane collaboration has played a major role in tracking down bias, and in fact, it's the only organization I know of that gives an award for criticizing or recognizing bias in itself. But all of this identification of bias has led to eroded trust in systematic reviews, published research, and science itself. This has left us in a very, very bad place. Science and scientific experts are vilified. What are we as researchers supposed to do? How can we focus peer review on reducing bias and rebuilding trust? So today's theme is problems, and we have lots of them. But the Peer Review Congress has also contributed to not only identifying problems related to bias, but to testing solutions for the problems. I put meta-research up there as a type of solution because it's the only type of work that lets us know what type of biases are occurring across broad areas of research, not just within a single study. And that's the first thing we need to do with bias, is expose it. We've made great progress in terms of protocol publication and open data access and reporting standards to tackle different types of reporting bias. And you statisticians in the audience will be happy to know that I list you as a solution rather to a problem, because your growing role as editors and peer reviewers helps to reduce bias in analysis. But I still think that we have bias in interpretation or presentation of findings, called spin, and funding and conflict of interest biases that are not quite being addressed yet. And I will be talking about this later. And the caveats for most of these solutions are that they are often developed for randomized control trials only, and they're not uniformly applied. But another characteristic of all of these solutions is that most of them deal with the problem by the provision of more and more information. So we know that the availability of supplemental files and data sets has been increasing. Asante and colleagues have shown that the number of data sets being shared annually in data repositories has increased by more than 400% in the last 5 years. Annette Flanagan has told me that in 2016, about 57% of major manuscripts reporting original research published in JAMA had online-only supplements. And you'll hear more about this study during the poster sessions at this meeting. And it's not just the number of files and data sets that are increasing, but their sheer mass. Mark Reed, who's a science researcher at the Charles Perkins Center, provided me with this example from one of his typical papers, where he's published a 14-page paper with 86 pages of supplemental files. So more information has also been used to address corporate influence on research. As you see there on the left, we have extensive financial disclosures. This is a typical disclosure statement, but any conflicts of interest in that statement may be hiding in too much information. Despite this, we know that there are also undisclosed ties, and we'll be hearing more about that at this Congress. And as shown on the right, the disclosure regarding religious practices, disclosures may be muddied with information that does not meet the criteria for a conflict of interest. And as we see on the lower right there, even when nothing is disclosed, too much confusing information can be provided about actual, competing, and potential interests. Oh, sorry, I ran off my box there. So disclosure of financial ties is insufficient to manage conflicts of interest. We have shown that undisclosed ties remain, and disclosure is difficult to enforce by journals. Disclosure does not prevent bias in research. In fact, all of the research done on bias has been done based on what's been disclosed. It makes those giving advice more biased, as has been shown in psychological experiments from Lowenstein and colleagues. And as the BMJ presented at this conference years ago, if you put funding disclosures on a paper, it does make the readers more critical, but they're as likely to believe the findings. And I know there'll be more presented along these lines by BMJ at this meeting. So in summary, disclosure is not a management strategy, and it's necessary, but not sufficient. We also have more and more information on funding sources of studies. So a number of systematic reviews across a wide range of topics, including drugs, tobacco, nutrition, and chemicals, have shown that funding source is associated with biased results and conclusions. For example, on the left, this recent Cochrane review included 75 studies that examined the association of pharmaceutical industry funding with the results of drug studies. And this is just one meta-analysis from that Cochrane review showing that industry-sponsored studies more often had statistically significant favorable efficacy results. But the meta-analysis on the right shows that the conclusions of food industry-sponsored studies favor the products made by the sponsoring company. Veronica Yank at a previous peer review congress also showed that industry funding of meta-analyses was associated with disagreement between results and conclusions, and the conclusions were more favorable. And in fact, the association of funding source with conclusions of studies has been studied far more often than the association of funding source with the actual results of the studies. And this may be because spin can occur. The conclusions of studies can be easily manipulated through bias, presentation, or interpretation, and you're going to hear a lot more about spin at this Congress. So in sum, the provision of more information has made little headway on tackling our problems related to conflicts of interest or spin. More information has actually led to more problems. There may be too much information to be peer-reviewed, and we don't really know what's peer-reviewed or not, although we'll be learning a bit more at this meeting. So the bottom line is that peer review has gotten harder and there's more of it to do, but what do we really know about peer review? Oh, and there is more. I forgot to mention that even after your paper is accepted, you're asked for more information. Authors are asked to provide images, web links, photos, biographies, etc. And this is actually more opportunities to spin the results of your paper. So now I'll move on to what do we know about peer review. So the first thing we know about peer review is that we believe in peer review. In general, scientists think that peer review is a good thing, although young scientists are less likely to hold this view. Peer review is still the gold standard of scientific publication in a variety of academic and policy settings. Peer-reviewed publications are valued more for promotion and tenure. Regulatory agencies often allow only the submission of peer-reviewed articles as scientific evidence. And even corporate interests have learned that publishing their science in peer-reviewed journals will give it credibility. This is an interesting document from the tobacco industry where someone from Philip Morris was taking notes on a presentation I gave at an earlier peer review congress. This presentation was on publication bias. And the tobacco industry person taking the notes didn't think much of my presentation, but the point here is that it notes that tobacco industry sponsored work must be of high quality and must be published in the peer-reviewed literature. So there was recognition that this is what gave the tobacco industry sponsored work credibility. So we believe in peer review, but we're still not quite sure what it is. At an earlier peer review congress in 2001, my colleagues and I presented a proposal for structured reporting of peer review, which was to have those elements shown there on the left. However, recent papers have noted that detailed descriptions of peer review are still sparse, so our recommendation never really caught on. And the reason we made that recommendation is we were having a hard time figuring out what peer review was happening at journals. My understanding of open peer review, for example, is that the identities of the authors and peer reviewers are known to each other. However, a recent systematic review found that these definitions were often contradictory and overlapping, and in fact, there were 200 definitions in all of open peer review. So now I'm very confused after looking at that. And this is made worse by the fact that there are many, many types of peer review. We have preprints, which are sold to authors as manuscript marketplaces or a place to get your manuscript snatched up and published, on to post-publication review, cascading review, portable review, my understanding of which is that's basically outsourcing of review that's not done by journals at all. So although a lot of energy has been devoted to testing these different models for peer review, it's unclear what unresolved problems we're trying to solve with these models. So I'd like to know how these models are combating conflicts of interest or spin, for example. We also know about peer review that it takes time, and again, I show a quote from Drummond. I couldn't have said it better myself. good peer review does take time. And we know a lot about the process of peer review, everything from major and minor changes to suggested, to how long it takes, the quality of the reviews, the cost, the time, etc. And in general, these are what in clinical medicine we would call surrogate outcomes, the characteristics of the reviews and not of the papers themselves. So it would be good to see more research focusing on the papers. And lastly, peer review can go very, very wrong. What this figure shows here, if you use the citation rate that Drummond was mentioning, which is still controversial, but here I'm using it, as a proxy for paper quality, in our prospective study of over 1,000 manuscripts submitted to 3 high-impact journals, we followed these manuscripts to see what happened, even if they were rejected from the journal. And as you'll see here on the right side of the figure, the red dots show the 14 most highly cited papers. And those 14 most highly cited papers were rejected initially by these 3 journals and published elsewhere before they became the most highly cited. And we also know about other problems. There's problems with stolen papers, stolen ideas, or my favorite was a pre-embargo leak of one of my accepted papers by an industry-affiliated reviewer. So I suggest refocusing research on peer review towards tackling some of the biggest and most enduring problems we have with scientific publication, and 2 problems that have not been solved by the provision of more information. These are conflicts of interest and spin. So funding bias and conflicts of interest are a problem because I've already mentioned there's a great deal of evidence suggesting that these biases exist even when you control for a myriad of factors such as the methodologies of the papers themselves. We also have more disclosure, although it's still far from 100%. As I mentioned, we know that disclosure does not reduce bias. And we see high-profile research funded by companies or conducted by investigators with financial ties to companies. And as I've written with Quinn Grundy, these financial influences have a megaphone effect because they can bias multiple aspects of the research in the same direction and affect multiple individuals in the same way. So what can journals and peer reviewers do to stem this avalanche of industry-induced bias? First, they could stop publishing industry-sponsored research, or at least studies that are largely conducted for marketing purposes. And I know that over the years, many journals have discussed better ways to identify, for example, seeding trials or drug trials that are used primarily for marketing purposes. And this suggestion is often dismissed, but it's really not so radical because this has been done for tobacco industry-sponsored research, which a number of journals do not publish. Second, we could penalize authors and companies for not accurately disclosing financial ties. Although we have more and more databases in which to look for financial ties, these do not cover all researchers, nor are they comprehensive, and we still don't know the denominator of undisclosed ties, but we know there are undisclosed ties, and there appears to be no consequences when these are not disclosed to journals. Next, we can provide information on funding sources and all disclosures to peer reviewers. This is not done across the board by all journals. And then we can require peer reviewers to use a tool to assess funding disclosures and author conflicts of interest as risk of bias, just as journals often provide tools for assessing methodologies of the papers. Peer reviewers should then comment on how they think these biases might affect the design or analysis. And for studies with financial ties, we could recruit specialist reviewers to pore over the design, the data, and the analysis. This is already done by a number of organizations that review drug trials, for example, the Pharmaceutical Benefits Advisory Committee in Australia. And as Sue Hill showed in a 2000 analysis of these applications, this committee, with paid experts with data already organized for it, were unable to complete reviews in less than 2 weeks. So this does not solve the time problem. and it doesn't look at the conclusions of papers. So it fails also to address the problem of spin. So I've already defined spin, and as we'll hear later today, there are actually many, many definitions of spin out there. And we still have questions about where spin comes from. Mostly individual characteristics of investigators and studies have been examined in relation to spin. However, systemic problems that may promote spin are rarely addressed, and one problem that is very rarely addressed to my knowledge is whether peer reviewers can catch spin and the role of editors and journals in assessing spin, or in fact, in even contributing to spin. I'm sure many of you as authors might recall the time when someone has asked you to add an alternate interpretation or additional interpretations to your conclusions, which you might have felt was being asked to spin your results. So what can journals do about spin? We can develop checklists for spin that's applicable to all types of studies. I know that this is, there's some work on this for trials, but not for other studies. We can have reviewers spend their time reviewing the methods, the results, and the supplementary files. As I noted, this takes time, but then we could leave the conclusions for editorial review, for example. But before that, we need to know a lot more about the editor's roles in spin. We could get rid of discussion sections altogether, although this certainly wouldn't eliminate interpretation in your study analysis. And so a more practical suggestion might be to publish multiple discussions. And many journals doing open peer review are already doing this. They're inviting multiple interpretations of their data. But when we do this, we need to be aware of the megaphone effect, because the interpretations that are published may be those that express a dominant conflicted view. So these reforms, and I think experimenting with them is very worthwhile, but these reforms would be the death for journal articles and many journals as we know them. And now the death of journals has been predicted by many, including myself, over the last 20 years, and so you can see I'm not very good at predicting the future. But as we move through this meeting, I hope we see more bold suggestions for tackling some of our unsolved problems with peer review. Thank you.
That was terrific. Excuse me. We're going to have no questions today because I had to give that stuff at the start. And you'll have plenty of time to ask Lisa stuff. Mike Berkowitz has something to say at this point about Mike, come out from your burrow. It's where I keep him. Thank you. The moderator of the next session is Veronique Kierma, who's coming to the microphone. She was at Nature, now she's with PLOS. Where are, Thank you.
Thank you. I'll ask the presenters to actually join us on the podium so we can expedite transitions. Good morning, everyone. It's a great pleasure to be moderating this first session. which is dedicated to bias associated with conflict of interest and peer review, and was very pointedly introduced by the plenary talk by Elisa Bero. We're going to have 4 presentations, and you will have the opportunity to ask questions after each of the presentation. The first presentation is by Quinn Grundy. Quinn is a postdoctoral research fellow at the University of Sydney, and she will talk to us about the prevalence of conflict of interest disclosures in biomedical research. Thank you.
Thank you. Author conflict of interest may be associated with bias in research and their interpretation. Conflict of interest disclosures are thus widely required in biomedical publishing per the recommendations of the International Committee of Medical Journal Editors, and thus they can act as a signal for risk of bias in research. Despite the increasing prevalence of this practice, we still lack understanding of the extent of conflicts of interest in biomedical research for a number of reasons. Firstly, disclosures are merely a proxy for actual conflict of interest. They rely on self-report, and thus, as Lisa has highlighted, are likely underestimates of conflicts of interest. And we still see a great variation in reporting practices across journals. Despite the lack of data around prevalence, the discourse around conflicts of interest in research suggests they're widespread, normal, even unavoidable, if not desirable. The aim of this study was to estimate the prevalence of conflict of interest disclosures in biomedical research irrespective of discipline or clinical area or study design. And a secondary aim was to determine whether disclosed conflict of interest were associated with article characteristics, such as type or focus, including attention in the scientific literature and mainstream and social media. We randomly sampled articles that were published during 2016 in biomedical journals listed in PubMed, and also reporting conformance to the International Committee of Medical Journal Editors' editorial policies. We included 1,002 articles in the end based on an expected proportion of 20% of articles and a predefined target sample size. We included primary research articles, but also commentaries, editorials, narrative reviews, systematic reviews, and meta-analyses. We developed an a priori coding manual based on the National Academy of Medicine definition of conflict of interest and the ICMJE taxonomy for conflicts of interest. For all analyses, we grouped articles into 3 categories. Firstly, primary research, which included clinical trials, observational studies, case reports, commentaries, editorials, and narrative reviews, and lastly, systematic reviews and meta-analyses. We considered author conflict of interest and funding source disclosures separately, extracting these statements verbatim, regardless as whether they were labeled as such. We defined a conflict of interest as that pertaining to the individual author, whereas a funding disclosure was support pertaining exclusively to the current work. We classified the focus of an article as related to drugs, devices, or surgical procedures, or neither, and the focus was determined by whether the authors had mentioned a drug, device, or procedure in the title or abstract. And finally, we examined 2 attention-related factors, including journal impact factor from the 2016 journal citation reports, and the measure of social and mainstream media attention as the altmetric application programming interface. This graph shows the proportion of articles with disclosed conflicts of interest in orange, a missing conflict of interest statement in white, and a statement of no conflict of interest in green, in aggregate and then by article type. The horizontal lines represent a 95% confidence interval on the prevalence. Overall, 23% of articles in our sample disclosed a conflict of interest, About 2/3 made a statement that the authors had no conflicts, and only 14% were missing a conflict of interest statement at all. However, when we broke it down by article type, you can see that the prevalence of disclosed conflict was significantly higher at about 31% among commentaries, editorials, narrative reviews, in contrast to primary research sitting about 19%. Similarly, we can see a pattern when we break the prevalence down by the focus of the article. So again, the disclosed conflicts of interest in orange, sitting around 19% for primary research. But as we look at the different foci of the articles, you can see that it increases for devices and surgical focused articles, and then it is around 30% for primary research articles focused on drugs. We experienced a number of methodological challenges in doing this work. For example, we documented 130 different ways of stating the authors have no conflicts. We broadly grouped these into 3 themes that have variable meaning. So firstly, the sense that there is none declared. So for example, the authors did not declare any conflicts of interest, contrasted with nothing to declare, so stating there are no conflicts of interest, versus no relevant conflicts, such as stating no conflict of interest exists in this paper. The longest statement we found was 63 words long. Nearly 40% of conflict of interest disclosures contained extraneous biographical information, long histories of employment, committee memberships, or misplaced funding information, such as current or previous public and not-for-profit research funding. The statements were also highly inconsistent and difficult to locate. We opted for duplicate data extraction despite extracting these statements verbatim, largely due to the difficulty in finding them. We found author conflict of interest and study funding disclosures were often conflated, and that not all disclosures were located in the article PDF, but were often located online or in supplementary materials. We found 2 attention factors to be interesting in terms of their relationship with disclosed conflicts of interest. So the graph on your left shows on the y-axis the proportion of articles published in journals with an impact factor of X or higher. And you can see that the orange line, representing articles that disclosed a conflict of interest, was consistently higher than those in green that stated no conflicts. And similarly, we see the same pattern on the right with the altmetric score. So articles, again in orange, disclosing a conflict of interest consistently had a higher proportion with a higher altmetric score than those without. And we found this pattern across all subgroups for both attention factors, that the median journal impact factor or altmetric score was significantly higher for articles with disclosed conflicts of interest versus those that did not. Just under 1 in 4 biomedical research articles that are conforming to the ICMJE editorial policies and indexed in PubMed are disclosing a conflict of interest. And interestingly, this estimate has been relatively consistent for more than a decade, and rather than reflecting the sense that conflicts of interest are the norm, represents a minority. However, we did find that disclosed conflicts of interest are concentrated among certain types of studies. For example, commentaries, editorials, which could reflect the fact that these authors may be both more influential and more likely to be targeted by companies for these kinds of relationships. But I think it also may reflect that consumers are disproportionately exposed to research by authors with conflicts of interest, which can contribute to the sense that conflicts are normalized and erode political will to develop strong management policies. I think this work also suggests the need to revisit reporting requirements, such as separating funding and conflict of interest disclosures so that we can understand their independent contribution to bias in research. standardized reporting requirements across journals, and then perhaps revisiting the idea of a registry where we have author rather than article-specific disclosures, much like the Open Payments Database for United States physicians. I would just like to thank my co-authors Adam Dunn, Florence Bourgeois, and Elisa Bero. Thank you very much.
Thank you very much, Quinn. Are there any questions for Quinn in the audience? There are a few standing microphones, so if you have a question, please come to the microphone and announce yourself. I'm going to actually start with a question of my own while you are organizing your thoughts. You focused your study on on journals that were complying with ICMG or were signatories of members of ICMG. It strikes me that the absence of any disclosure is actually quite low in your sample compared to, I think, other samples that we've seen in the literature that were not focused on ICM. Is that something you've noticed, or is this something you can elaborate on?
Yes, so again, we focused on what could be considered a subset of journals with the best practices for disclosure. What we did note, however, was for conflict of interest is doing better than disclosure. So whereas only about 14% of articles were missing a conflict of interest disclosure, funding was not doing so well. So about 41% of our sample was missing a disclosure about funding for the current work. And so I think that's where we're again recommending a standardization of reporting requirements, separating author conflict of interest from study funding, because it's unclear in those cases whether that missing meant there truly was no support or whether that was an omission.
Right. Are there any questions? Yeah, we have a question at the microphone there.
Hi, my name's Pippa Smart. Very interesting study. I've got two questions. The first one is, when you were analysing the articles, were you looking specifically for articles that had a conflict of interest section? So would it be possible that you might have missed some statements of conflict of interest that in some journals are put in the acknowledgements?
So that is part of the methodological challenges that we encountered, and my co-author Adam Dunn wanted me to impress upon you how difficult these were to find, because as you know, frequently they're not labeled as such. So that's why we did have two independent reviewers extracting that data. So it's occasionally under acknowledgements, occasionally funding source and conflict of interest disclosures are within a generic disclosure section. Sometimes those disclosures were located online. So no, we didn't extract only those explicitly labeled as such. That was a double negative. But we looked for that, and there was an element of interpretation then involved when that was reported together.
Thank you. I have a second question. The correlation between the high impact factor journals and the disclosure seems perfectly understandable, but I wondered if you had any thoughts about the altmetric scores.
It's interesting, and I think we're going to do some more analysis, because I think it's highly likely, first of all, that journal impact factor and altmetric score are also correlated. Yeah. And I don't have that information as yet. So it could be that in biomedical publishing that those two now go hand in hand. But I do think that, and Lisa has referenced this idea of a megaphone effect, that there's a bit of a chicken and egg here, whether influential authors and influential studies are targeted for financial relationships, or whether they are receiving attention because they are influential, and it's unclear what the direction that mechanism, likely it's going both ways. But I do think that this is the effect of sponsorship in another form simply than research funding.
Thank you.
Thank you.
Hi, Vivian Bachelet from MedWave and USACH University in Chile. I enjoyed your presentation very much. So my question is, according to the ICMJE recommendations, to my understanding, each author should disclose individually the conflicts of interest. However, we tend to see in published articles that it's sort of like a over-encompassing declaration on behalf of everybody else. And we also see that corresponding authors will declare on behalf of the other authors, therefore setting up a mantle of sort of cover-up on what's going on. Do you have any thoughts on that? Were you able to gain any insight on who is actually declaring what on behalf of whom? If I got that right in my English, I don't know.
Yeah, the short answer is no, and I think that is one of the challenges that needs to be tackled. So really our unit of analysis is the study. And the way that disclosures are currently reported means that an article is conflicted rather than an individual author. My colleague Adam Dunn has recently published a commentary in Nature where he proposes a registry model so that there would be a central repository for authors to declare conflicts, so those could be tied to individuals rather than having this composite disclosure for a published work.
Yes, congrats also for your presentation. I'm sorry for my horrible English. I have to say first that in the 90s, I worked full-time for the pharmaceutical industry. Then I fully agree with the interpretation of your data that you have done now here in the discussion, but not before. If you show your graph, can you go 3 slides back, please?
This one or the
Yes,
previous?
that one, perfect. Okay. So my point is that the two groups are not randomized groups from ideas or from hypotheses or from papers, but are just two observational groups that might differ in some things. For example, we can assume that people investing money in research might invest money in the more promising and the more interesting research. If so, this will also happen. So I'm just adding another interpretation. Yeah. I fully agree with your interpretations, but there are others.
No, and I think this is this idea that it's probably a multi-direction relationship, so that the more influential authors and studies are going to receive more attention. They may also be more likely to have a conflict of interest. Thank you.
Yeah, perfect. Mark Dewey from Berlin. You noted that about more than 10% had missing information, right? Was that in any way related to the impact factor? Because it may be due to underreporting in the low impact factor journals too, right?
Yeah, and that's something I think we will continue to explore. So there were a number of other article characteristics that we've looked at, so including publisher, journal. Also, we included both animal and human research. And so I think in the next phase of this study, we will see if there are other patterns within that and see if we could build a model. And certainly, again, acknowledging that this, being indexed in PubMed and conforming to the ICMJE policies, that we might be looking at a specific subset.
Theo and Trish, I don't know, do we have any online questions? No. Well, please join me in thanking Quinn for her presentation. We will now hear from Camilla Hansen. Camilla is a PhD student at the Center for Evidence-Based Medicine at the Odense University Hospital in Denmark. She will present her study on the influence of industry funding and other financial conflicts of interest on the outcomes and quality of systematic reviews. Thank you, Camilla.
Thank you. Okay, so good morning. First of all, I would like to thank for the opportunity to present our study here today. I'm going to tell you a little bit about what we found in our Cochrane review on financial conflicts of interest in systematic reviews. First of all, do we have any conflicts of interest in giving this presentation on conflicts of interest? Peter Goethe, who is co-author of the review, is also co-author of 2 of the studies that we have included. To minimize the potential influence from this, Peter was not involved in the study inclusion, data extraction, risk of bias assessment, or the data analysis. Otherwise, we have nothing to declare. So we do know that financial conflicts of interest impact on primary research. Most recently, this has been shown in a Cochrane review published earlier this year. This review was based on 75 empirical studies. Contrary, only a few studies have investigated conflicts of interest in systematic reviews, but we do suspect that conflicts of interest may also impact on the reviews. To our knowledge, existing studies have not been summarized and investigated in a systematic review. So, based on this, we wanted to investigate whether financial conflicts of interest are associated with estimated effect sizes, which refers to the specific numbers in a result section of a review, statistically favorable results, which refers to the direction and the statistical significance of the result section, and also favorable conclusions and the quality of the reviews. So we decided to use the definitions of financial conflicts of interest used by the authors of the included studies. So for example, one of our included studies defined financial conflicts of interest as employment, funding of grants paid to an author or a research group, and the funding of medical writers for review. But we did also investigate other definitions of financial conflicts of interest in different subgroup analyses. So we did the review according to standard Cochrane methodology, meaning that 2 of us did the searches, the study inclusion, the data extraction, and the risk of bias assessment. We included observational studies that compared industry and non-industry reviews and investigated at least one of the outcomes that are outlined in the objectives. We analyzed our data using RevMan and random effects models. So based on our searches, we included 9 studies. They were published between 2006 and 2017 and included a total of almost 1,000 systematic reviews with a median number of 121. We were able to get unpublished data from 4 of our studies and protocols from 5 of our studies. We based our validity assessment on 3 different criteria. We looked at the study inclusion process and the coding of financial conflicts of interest and outcomes done by the authors of the included studies. Most importantly, we looked at the comparability of the systematic reviews because we wanted to assess whether the systematic reviews were similar in all other important aspects besides from financial conflicts of interest. So overall, we assessed 2 of our studies as low risk of bias studies because these 2 studies had low risk of bias in all 3 criteria. And as you may see from the figure, we only had 2 studies that investigated comparable samples of systematic reviews. Okay, so for the funny part. We had 2 outcomes that were related to the result sections of the review, and we found 1 study that investigated effect sizes, and this study found similar effect sizes between industry and non-industry reviews. Similar, we also found 1 study that investigated statistically favorable results, and our analysis of this study also found a similar frequency between industry and non-industry reviews. So we found a total of 6 studies that investigated favorable conclusions, and our pooled analysis of these 6 studies showed that industry reviews more often had favorable conclusions compared with non-industry reviews. We did find a relative risk of 1.96, but we also had substantial statistical heterogeneity with an I-square of 73%. So the observational studies measured quality by using a number of different tools. For example, the Oxman-Gaia tool and the Amsterdam checklist were used. In total, we were able to pull information on 11 different dimensions of quality. For the majority of our dimensions, we did not find a statistical significant difference. I have marked an example with a red circle on the presentation, and this shows that there's no difference in how often industry and non-industry reviews have appropriate search methods. For 2 of the dimensions, we did find a statistical significant difference. I have marked an example with a blue circle, and this showed that industry reviews less often assessed risk of bias compared with non-industry reviews. Overall, we did find a trend because all of our effect estimates indicate that industry reviews have lower quality than non-industry reviews. We tested our main findings in a number of different subgroup and sensitivity analyses. In particular, we focused on the risk of bias, the types of systematic reviews, and the definitions of financial conflicts of interest and outcomes used by the authors of the included studies. To keep it short, in all the analyses, we found similar results as our primary analyses. Inspired by the GRADE approach, we assessed the certainty of the evidence. We did choose to use moderate certainty as a starting point instead of low evidence. For effect sizes, we assessed the certainty as low because our findings are based on only 1 observational study, and we do believe that more research may impact on the estimate and also our confidence in the estimate. For statistically favorable results, we assess the certainty as very low, because once again, our findings are based on only 1 observational study. We assess this study as a high risk of bias study, and we found quite wide confidence intervals also. Finally, we assessed the certainty for favorable conclusions as moderate, because our findings are based on 6 observational studies, and we did find a stronger association among the low risk of bias studies compared with the high risk of bias studies. So, we had 2 main challenges. First of all, we found substantial statistical heterogeneity in our analysis of favorable conclusions. We did investigate this in subgroup and sensitivity analyses, and these analyses indicated that the definition of financial conflicts of interest and outcomes, and also the inclusion of both Cochrane and non-Cochrane reviews may have added to this heterogeneity. Second, we do believe that there's no validated criteria for assessing risk of bias in these types of studies, so we had to rely on criteria that we defined ourselves. And beside from that, we only found 2 studies that had comparable samples of systematic reviews. However, we do believe that based on our findings, industry reviews should be interpreted and also included in clinical guidelines with caution. We suggest that future research focus on establishing whether financial conflicts of interest impact directly on the results of the reviews, and future research should, of course, investigate comparable samples of systematic reviews and should also investigate different types of conflicts of interest and also non-financial conflicts of interest. So, in conclusion, systematic reviews with financial conflicts of interest more often have conclusions that are favorable towards the experimental intervention and also tend to have lower quality than systematic reviews without financial conflicts of interest. It remains, however, unclear whether financial conflicts of interest impact directly on the results of the systematic reviews. So, thank you.
Questions for Camilla? Please come to the microphone.
Yes, congrats also for your presentation. I have exactly the same conflict of interest as before, but I would like to congratulate you for your slide about the methodology of the quality. That is in agreement with my previous expectations. I mean, industry usually knows which studies have been done before they conduct the systematic review. So, if they ask for a systematic review, they are probably knowing what the results of the systematic review will be. That's a feeling. I have no data on this. And let me say two other things. Can you go back to your slides, please?
Yeah, which one?
The previous one, not the next one. Previous one, and then again previous one. Previous one. Another one, please, another one. Let's go.
I have a lot of slides.
That's yes, that's the slide that I congratulate you. That's wonderful. I think those results are very, very important, and you have to highlight this. And then go again, back again, please.
Oh, that was one too far.
Okay. This is just one. There is, in clinical trials, there are two main differences between sponsored trials and not sponsored trials. One of the differences is that usually sponsored trials are highly powered. That means that if the alternative hypothesis is true, they have a higher probability to have significant results. So my suggestion to you is to concentrate more on effect size, on comparing effect size, than on comparing p-values. Because p-values from industry, well-powered trials, could be more significant just because they have more power, just all. But effect size, that's nice. And if you can go further to the previous one, let me say a very, very difficult point that I really don't know the answer, really. Lawyers, you know, they used to say, please never ask a question if you don't know the answer. There are two kinds of research. When you perform a confirmatory trial, usually you ask the clinician for the effect size. And the clinician say, that's what I want to know. How can I give to you the effect size? So those confirmatory trials are usually more on the development phase of a drug. You know what is happening, and you are just looking for a documentation for this effect. So my point here, and I repeat, I don't know the answer, is that previously we might try to split the data to make a subgroup analysis, looking for trials with a previously stated hypothesis, really based on other previous trials that maybe are more on the development phase, and the other trials that are more on the exploratory, on the truly research phase.
So
I know that you are based.
Can you wrap up your question, please?
Sorry?
Can you wrap up the question so
Repeat.
that wrap up so that we can hear from the speaker?
Yes. Okay. That's enough. Thank you. I think I already did. The point is that. Well, okay. That's all.
Thank you. Well, I agree with your point on effect estimates. I think, as Lisa said earlier, it's something that has not been investigated that much, and it's something that definitely needs more attention.
Hello, I'm George Lundberg from San Francisco. Your study deals with industry sponsorship and conflicts of interest. How did the group consider physician companies and hospital companies as part of industry, or did they?
I think in general the studies that we included would define hospital industry as non-industry reviews, as far as I remember. And I think I would agree with that non-profit organizations are non-industry. Did I understand your question correct?
You raised the issue of profit-making versus non-profit. Is there a difference, and in which countries?
That's a good question. That's not something that I can answer right now, but I would be happy to return with an answer later today.
I also had a question about, I don't know if your sample size allows you to address that, but you looked at a fairly large span of time, so I think it was studies as early as 2006. Yeah. Did you see anything in terms of a longitudinal effect of improvement or
well, we didn't
decline?
Investigate that because the sample didn't allow us to, right. But that's definitely something that would be worth investigating.
Mm-hmm. Any other questions in the room? No? Do we have anything, Theo? No? People who are following online, you are absolutely welcome to ask questions. So, okay, thanks very much, Camilla. Our next presentation will be by Elisa de Ranieri. Elisa is head of editorial process and data analytics for the Nature journals. She will present her analysis of the uptake and outcome of an author-selected single-blind versus double-blind peer review at the Nature journals. Thank you, Elisa.
Thank you, Veronique. Good morning, everyone. And first of all, I would like to thank the organizer for giving me the opportunity to present our work here. And just because we are disclosing conflict of interest, I would like to say that all authors on this work are or have been employed by Springer Nature, who owns and publishes the Nature journals. The aim of the study was to start investigating whether there is any implicit bias in peer review, particularly at the Nature titles. The Nature titles introduced double-blind peer review as an optional author service back in 2015 as a measure that might prevent potential referee bias. So in this study, what we did was to compare single and double-blind papers that were submitted to the Nature titles to identify any potential referee bias against characteristics of the authors such as the gender, the country, or their institutional affiliation. The questions that we were trying to address were who are the authors that choose double-blind in the first place, and also whether there are any differences that we can observe between peer review outcomes of various review models. And ultimately, we want to answer the question, is there any evidence for peer review bias? The data included about 130,000 submissions of primary research that were received at Nature, Nature Communications, and 23 of the Nature sister titles spanning all of the research disciplines. These papers were submitted over a 2-year period between 2015 and 2017 and included both direct submissions and transfers between journals. Authors could choose at submission whether they were opting in for double-blind as an option or whether they would stick to single-blind. And this was possible only for the direct submissions, not for the transfers where they couldn't modify their choice anymore. And editors were always aware of the characteristics of the authors and also were aware of which choice of review model they had made. In all of these studies that I'm going to present, we use the corresponding author as a proxy for authors. We analyzed several characteristics, starting with the gender. So we assigned female, male, or not assigned as a categories, using the first name of the corresponding author and a third-party service called Gender API. In doing so, we discarded about 30,000 records because they came back with a confidence level that was not good enough. We then also analyzed a measure of institutional prestige or institutional status, if you like, and we used, as a proxy, we've used the 2016 Times Higher Education World University Ranking for that. So what we did was to normalize the institution names using grid and then group those institutions in status groups using the THE ranking. So group 1 would be the group with the institutions with a higher status according to that ranking, where the ranking is between 1 and 10. Group 2 is from 11 to 100. Group 3 would be ranks that is above 101. And at the same step of the analysis, we also normalized the country names. We then performed descriptive statistics for data exploration and used Pearson chi-square and binomial tests for the analysis. So what we found is that 12% of our authors have chosen double-blind peer review, About 17% of authors are female, the rest are male, excluding those that we can't determine the gender of. And we have found that there is no significant difference in the distribution of peer review model by gender. So both female and male are as likely to choose double-blind peer review as each other. We then observed that there is a small but significant association between the journal tier and the review type. So here we analyzed if there are any differences in the percentage of double-blind peer review papers if we look at different tiers of Nature titles. So they will have a different perceived status, and we see that Nature, for example, which has the higher status, has a higher percentage of submissions that are received in the double-blind option. It's in the darker color on this graph, compared to the sister journals and Nature Communications. We then also observed that there is a correlation between the choice of peer review model and the perceived prestige or status of the institution as defined, as I was saying earlier, from the Times Higher Education World University Ranking. So here in this graph, what we see is that institutions that are in the group with the higher status, group 1, have a much smaller percentage of authors that choose double-blind peer review, about 4%, when we compare with group 3, which is 13%. We've also studied if there was any association between the country of the main affiliation of the corresponding author and the review type. What you see here are the itemization of the 10 countries that are responsible for 80% of the submissions, and we grouped every other countries under other in the row at the bottom. So what you see here is that the United States and China, which are the topmost and second topmost submitters respectively, they have very different very different take on the double-blind peer review uptake, as you can better see on this graph, in which countries are listed in order of number of submissions. You can see the United States as a prevalence of the single-blind peer review when we compare with China, who has a higher take on double-blind. At the bottom of the graph, you also see India, which has an even higher percentage of papers that are submitted with double-blind option, but we are talking here about, of 2,000 papers submitted from India, as opposed to about 33,000 submitted from the US. Finally, we were also interested in understanding whether there is some correlation between the review model and the peer review outcome. And we've seen that both at the stage of the first editorial screening and later on when a decision is made post-review, whether the paper is finally accepted or rejected, there is quite a large correlation. Oh, sorry, I didn't do that. There's quite a correlation between the success and the peer review model. Here you can see that both at the stage of sent to review, the first editorial screening, and the accepted after review, which is the final stage, double-blind papers don't do as well as single-blind ones. And only about a third of double-blind papers is sent to review compared to single-blind, and only about half is then ultimately accepted as opposed to the single-blind case. So finally, what we could address with this study is the question on who chooses the double-blind option. And we have found that while there are no significant differences in the distribution by gender, there are quite significant ones in terms of the geographical origin of the authors, and also in terms of the prestige, the perceived prestige of the journal the authors submit to and of the institutions that they come from. And this somehow was expected. I'm a little bit surprised myself by the fact that we didn't observe a difference by gender, which I was expecting as the ones that we've seen in terms of country and institutions. And then also we could conclude that the double-blind option is linked to less successful peer review outcome. And this can be due to the objective quality of the papers, or could be due to a bias that editors and peer reviewers might have with regard to the peer review model itself. So of all the questions that we were trying to address at the beginning, we've sort of addressed the first two, but the ones that we are really quite far away from addressing is whether there is any evidence for reviewer bias at our journals. Because when we try to look at, for example, the gender distribution of accepted papers, we can see that from the data that we have, that there is a higher percentage of papers that are accepted under the double-blind review model that have female corresponding authors than there is, sorry, I'm not doing this, I'm not sure why it keeps flipping. Effectively, female corresponding authors are accepted more frequently under double-blind and single-blind model, but the opposite is true for single-blind. So this would be quite an interesting conclusion. Unfortunately, because of the very small numbers of papers that we are talking about, these results are not statistically significant, so we can't really conclude that this is a trend. And finally, a few words on the limitations of this work. As I was saying, we didn't have enough data, and this is the main problem. We've calculated that in order for us to make conclusions that are statistically significant, we would have to wait 100 years, which is not practical for most purposes. We didn't do any multivariate analysis or have any independent measure for manuscript quality. We didn't analyze the outcome post-review by gender and country of referees or study the uptake by seniority of corresponding author or by research area. And neither will we ensure that referees were actually blinded to authorship, meaning we didn't check whether manuscripts were posted on preprints servers. So ultimately, this analysis would have been much more meaningful if double-blind peer review was mandated rather than optional. And to conclude, what we wanted to achieve here was to identify reviewer bias, and we still have work to do, as I was saying, in terms of studying the outcome by gender, country, institutions, and then we have to find a way of addressing it if we find it, and this making double-blind peer review compulsory would be one idea, or blinding editors could be another idea, and even running a bias awareness campaign, I think, would help. And with that, I would like to thank you for your attention.
Thank you, Elisa. Are there any questions in the audience first?
I have a question with respect to your failure to find what you expected to find with respect to gender influencing this decision. Do you have any reason to, do you have any insights into how frequently the person who was listed as the corresponding author was really making those decisions? And did you look, for example, what percentage of corresponding authors were the senior authors on those papers?
That's a very good question. As I was saying, we haven't analyzed seniority of the corresponding authors yet, but it's on the radar. And I do not have data to answer your first question on how do we know that the corresponding authors that's listed on the manuscript tracking system was actually making the decision. I only have anecdotal evidence of that. So unfortunately, we don't have a way to track it for so many submissions. We have to go with what we have. Thank you.
Hi, I'm Daniel Lucco from the American Physical Society, and we met before.
Yeah.
So I'm going to ask you a question that maybe you won't like, which is, what are you doing to correct for possible bias by the editors? This is specifically relevant in questions like whether to send a manuscript out for review or not, which is done in the absence of any referee feedback. So isn't it possible that editors could be biased not only towards institutions, authors, but also whether or not those authors choose double-blind review in the first place?
Yeah, that's a very good point. So as I was saying, the point of this study was mostly to analyze bias that peer reviewers have, because that's what double-blind peer review can address, right? This will not address any bias from the editors. So as I was saying, one option could be to have a trial, and some of our journals are thinking about this, to have a trial where we go triple blind, so the editors are blinded too. This is something that we are considering seriously, and I think a couple of journals will start implementing this trial in the next 12 months, if everything goes as planned. Yeah, so that's one thing that we can do, and obviously, I mean, we have to trust our editors who are professional. They're professional staff. They know what's at stake there, and they act responsibly. Obviously, everybody has unconscious bias. We're all human, and they are trained to ensure that any bias that they have doesn't affect the result. But I think going triple blind is possibly the way to go.
We're going to go on the other side of the room. Valda?
Hi, this is Valda Vincent from Science. And so You know, I'm really behind professional editors. But I was just battling to understand the slide that showed, I think you said 30% were going out, were being selected for review, but then they were being taken at 50% after review? And
Yeah.
unless I misunderstood, does that mean that the single blind are actually performing better at review?
The single blind perform better at both stages of review. So
No. So the double blind, though.
Yeah, there is the factor of a third become a factor of a half. So you're right in saying that it looks like the screening that editors do is harsher than the screening that peer reviewers do. This seems the case from the data.
Okay,
yes.
Thank you. I was surprised. Yeah.
Another question.
Pertti Salmen from the Finnish Medical Journal. We have just transferred from single blind peer review to double blind, and you could conclude that it's not very fair to give authors this option, because when they think that revealing their names has a positive effect, they can do that, and if they think that would have a negative effect, they hide it, and their reviewers know all this. So doesn't seem very fair.
You can look at it both ways, because I was quite baffled by this result, actually. Well, not baffled, but it surprised me that the fact that when people submit to Nature, for example, they go double blind more often than when they submit to Nature Communications, which is sort of the counter-argument towards what you were just saying, because it looks like when, you know, if you submit to a journal with a higher status, you might want to make your name way in if you are, you know, a very well-recognized PI, for example, then this doesn't seem to be the case. Obviously, this is very preliminary data, and we haven't analyzed for seniority of the corresponding authors or by research area, so I don't have evidence to back what I'm saying yet, but I think that there are arguments in both ways. It's my short answer.
Theo, we have an online question.
No, this is a question from me, I'm afraid, Veronique. Theo Bloom, BMJ, and I may be showing my statistical ignorance here, but I think you showed us that a lot more authors from China and India choose double-blind peer review, and a lot more of them are rejected. And I think we know that from other studies from PLOS and so on, that authors from China and India are more likely to be rejected. So how have you controlled for... So in a way, I'd be more interested in those within the US who choose double-blind versus single-blind, or within a country, rather than taking the countries that have high choice of double-blind and saying more of them are rejected.
If I understand correct, so we haven't studied the rejection rate by country, so this is just based on the submissions. We haven't correlated the outcome with the country, with the review model, so this is something that we have to do still. So here what we have done, we've simply said all the submissions that come from country A, this is the breakdown of double-blind and single-blind. This is all we have done at this stage.
But because we know that the rejection rate is different for those countries, in a way, I'm reassured by your result, because it says to me that even when you're blind to which country people come from, the rejection rate is the same.
Yeah, as I said, I can't really judge on whether the rejection rate is the same from this data, because I don't have the breakdown by country, but I see what you're saying in terms of countries that I think they are discriminated against, they tend to choose double-blind more, and this is something that was expected. Yes, thank you.
I'm going to interject with a question that we've received from Facebook, which is basically based on the analysis you've done, do you recommend single-blind, double-blind, or triple-blind review?
Well, if we could mandate double-blind, I think that would be the way to go, and the next stage that is triple-blind. I think that the fact that it's not mandated can sort of muddle the waters a bit, so double-blind I think could be the standard. This is my personal opinion, by the way, it's not the company opinion, but yeah, I think that double-blind should be mandated for all journals.
Michael Derringer, I'm relatively new to this business, so my question may be a little naive, but it seems to me that there's a major confounding factor here, that being the quality of the work. And I don't know how you separate that, but for instance, one might assume that poor quality work might request double blinding. So have you any comments or observations in that regard?
That's a very good question. As I was saying at the end, we haven't controlled for quality separately, which is it's a flaw of this study, if you like, but anecdotally, because I've been an editor for several years for our titles, and anecdotally, my experience was that the quality of what's submitted double-blind, it is inferior, and it's to what's submitted single-blind, and there might be several reasons for this, but I do not have data yet to back what I'm saying up. This is just anecdotal evidence.
Thank you, Fiona Godley from the BMJ, and just to say how great it is to have biomedical journals represented at the Peer Review Congress so prominently. So thank you for being here, and to Science and others of you who have joined the community. I just wanted to ask whether you had thought about open peer review as an option. You talked about triple blind as your preference. I just wanted to encourage Nature and other biomedical science journals to consider open peer review as an option, and also to take an evidence-based approach to evaluating that, because rather than jumping to one conclusion, certainly at the BMJ we have open peer review and pre-publication histories published, and we're doing the same with BMJ Open, and also we're about to launch BMJ Open Science. So we've got quite a big tradition of open peer review, and we think it works well. We think it's the way to go. We think it's great for credit as well as accountability for the peer reviewers, and we've done randomized trials of it. So I just would encourage you to include that as one of your options.
Yeah, we are making progress on that sense in that Nature now as a trial for referee accreditation, where the names of the referees gets published, while Nature Communications as another trial where they actually publish the reports. So we are making progress. Is that it's difficult to move in that direction, but we are making little progresses.
Good morning. I'm Sharon Quimby with American Academy of Neurology. And I was just thinking that in a mandated double-blind scenario, there's still going to be little breadcrumbs when you're looking at the study funding, the conflicts of interest, and the disclosure statements. And I just feel like that's also going to give peer reviewers and editors a clue as to who the authors are, who the the affiliated universities are. So I still think maybe there's a little balance of power issue there.
That's a very good point, and also some communities, such as the communities in the physical sciences, have a lot of, people post on preprints a lot, and that obviously goes against double-blind, because referees can just Google up the title and they see the authors. So yeah, there are all sorts of things to consider. This is a very good point. Thank you.
And folks often reference their own work, so you just have to look at the reference list.
Yeah, that's true.
I think we might have another question. In the interim, do you have any sense, Elisa, did you do any qualitative surveys, or what are the motivations of people? I mean, you've showed us the data about the gender and the affiliations, for example, but do you have a sense of the motivation of people who choose double-blind?
Again, this is anecdotal from my own experience as an editor, and I think authors that come from certain countries or from institutions that are not well recognized for academic excellence, they feel that they are being discriminated against, and this is a tool they have to, try to prevent referee bias. So I think that's why they choose it. And as I was saying, I was a little bit surprised that there wasn't any gender difference in the gender distribution for that, because normally I thought female authors tend to feel discriminated against.
Is there time for another question?
Yes, there is time for another question.
So my name is Hansen. I'm a medical student from Yale. So my question is, you showed that you excluded the papers where if you run the gender API and the confidence is less than 80%.
Yeah.
Not to add, I think there are another layer of complication here is that, for example, I ran my original Chinese name and it was showed that I was male. And so, so if you run that and if you set it as 80%, my paper would have been excluded. So this is just another layer that might impact how people with foreign first names to be considered. What do you think?
No, that's a very fair point, that normally for Asian names, it's where the difficulty lies in finding out the gender, and we can't do this manually for thousands of records. So that's, I take the point that there's this, the fact that we've discarded some of the results might affect certain ethnicities more than others.
We have time for one short question.
Sure. Kristen Mueller, Melanoma Research Alliance. Just a question, if you got feedback from reviewers at all. Was it easier or harder to find reviewers for the double-blind, or any assessment that way?
Again, anecdotally and from surveys that we run, people are not put off by double-blind.
Okay, thanks.
Thank you.
Thank you, Elisa. The last presentation in this session will be by Jory Lerback. Jory is a graduate student at the University of Utah, and she will present us a study on gender and age bias in peer review in the Earth and Space Science journals.
Thank you. So I'm a graduate student now, but I used to be a data analyst at the American Geophysical Union. The American Geophysical Union, or AGU, is Earth and Space Science's largest society and publisher. We publish about 6,000 papers per year. And earlier this year, Brooks and I published a demographic study of our editorial database, where we found that women are underrepresented as peer reviewers as compared to their participation as first authors and of members. This was including age data, so we can say that with confidence that this gap does not occur because we are choosing older reviewers, which are less female than younger age cohorts are. So taking a step back, how we can get this data is that because we're a membership society, our members self-identify with their gender, their age, and their country. And we're going to go through a little bit more of the results from our last study with updated information from 2016. And we match these demographic data to our editorial database, which, thanks to EJ Press, we have, and that sort of information is normally anonymous, but those actions are recorded in a way that we can match and do a sort of internal audit. And in the future, we would like to rather use ORCIDs for consistency. So in this match rate, we have pretty high match rates, and even in instances where we don't have very high match rates, we do have enough data where our results are significant. So to review with new data, we're looking at the percentage of female reviewers, and that's our y-axis. It goes up to 50% to represent gender parity. And the x-axis, you can see an aggregate of all ages in that first column, and then a breakdown by age cohort. So women reviewers are about 21% of all reviewers, and compared to members, first authors, and all authors, there is this gap, and that gap is consistent through age cohorts. And as a reference, women in Earth and Space Science is vaguely, or is pretty comparable to US STEM employment. So to figure out where this gap is coming from, we'll look at the suggestions from authors. So when authors are submitting their papers, they're thinking of submitting their paper and not whether they're equitably representing their science with who they're suggesting to review their paper. So women authors are in green. Sorry, the formatting has messed up a little. But women authors are suggesting female reviewers at about 22%, and male authors are suggesting female reviewers at about 15%. And broken down by age, you can see that women authors are representing a closer match to the actual authorship population. The story is pretty much the same with editors. Female editors are in green. They are inviting female reviewers at about 22%, and male editors in blue
are inviting female reviewers at about 18%. And again, women editors are more closely matching the actual publishing population. And AGU has worked with their editors for the last year or so about mitigating this bias, and we'd like to note that having more female editors is because they're more closely matching the actual publishing population. This is partly mitigating this bias, but it doesn't address issues of homophily, which was touched on in a recent eLife article by Helmer et al. So formatting on this is not great either. But the second two columns in each group are the suggestions and invitations of reviewers by both authors and editors. So women authors and editors suggest female reviewers at about 22%, and male authors and editors at about 17%. And this is very close to representing who people are authoring with. Women first authors are authoring with 22% women co-authors, and male first authors are authoring with 16% female co-authors. And so I would invite you to imagine that authors and editors are reflecting the worlds that they're working in and who they're publishing with when they're suggesting reviewers. And so this brings into this implicit bias towards representing who you're working with might bridge beyond just who is reviewing, but who you're authoring with and what that sort of network looks like. So you can imagine that women are a large and easily measurable group of underrepresented people, and this sort of dynamic of who you network with might apply to other groups of underrepresented people. So in light of this gap we found, GRL, Geophysical Research Letters, is AGU's largest journal, and we included a reminder to authors when they're about to suggest reviewers that data show that women are underrepresented at this step in the process, and to please think about women and underrepresented groups when you're suggesting reviewers to try to mitigate this gap that we found. So looking at the results of this experiment in GRL, the 3 months before are on the left of this, is the left group on this graph, and the 3 months after is on the right. And so female authors before and after this experiment started they have a slight jump in who they're recommending as reviewers, but male authors have a visible jump in who they're recommending, and that is statistically significant at this point. And so we were also wondering if this jump is just an increase of awareness in this sort of bias in who is reviewing. And so we looked at all of our journals before publication of this article and after. And there is a slight increase, but it is not statistically significant. And the last factor in what might be contributing to the gap in who is authoring versus who is reviewing is that women decline slightly more to review, and that's consistent through most years that we study. And this year, since publication, there's been quite a large, about 10% drop in decline rates by women. And there is also a drop in male decline rates. This data might be slightly skewed because it's just from the beginning of this year, and people might be declining more at the end of the year when things get a little more hectic, but we would like to note that that is a significant drop and that we'll need more data to really tell. So overall, in the 5 years of this study, the percentage of women as reviewers and invites and suggestions have been increasing, and there might be an acceleration of that increase in the last year since this has come to light. So in conclusion, this sort of audit, awareness, training, reminders, transparency might make a small difference, but we do need more data to fully evaluate. Thank you.
We have a question there.
Carrie Gross from Yale. Congratulations on a great study, because you not only demonstrated a disparity, but also began to rectify it. And just thinking about other potential remedies here, do you know if the particular journals involved are considering other approaches to perhaps help to ensure that female scientists are at the top of our mind when we're thinking about who to ask for a review, such as increasing the number of women who are invited to provide editorials or other comments within the journal pages?
I'm not sure about the editorials, but I know there is a big push in AGU for more women speakers at meetings. And general awareness campaigns might be in process.
Hi, Debbie Levine from the journal Radiology. I was just wondering, you gave a lot of percentages, and so it was percentage with respect to the societies that were represented by these journals. But if females are a very small percentage, then they're being asked to do a lot of different things to represent females in those areas. So what was the disparity of men to women in your cohort overall?
So women are about 30% of members in general, and so as distinct reviewers, they're asked to review less times per person than men are, but including more women and including a more diverse population should increase your pool of reviewers so that the burden of work that reviewing would be spread around more, if that answers your question.
George Lundberg again from Stanford, and the medical journal called Curious, C-U-R-E-U-S. A question for the moderator and any panelist. If a cardiologist writes a paper about results of treatment of a myocardial infarction, or an orthopedist writes a paper about the results of hip replacement surgery, or an ophthalmologist writes a paper about cataract surgery, or a radiologist writes a paper about imaging techniques, and none declare a conflict of interest, is the mere obvious nature of bias, they make their living doing what they're writing about, sufficient as disclosure or not?
You're asking discussion outside of the specific talk here about gender bias, is that correct? So are you asking whether expertise is a conflict of interest? Do I understand?
I'm asking whether if somebody makes their living doing what they're writing about and they don't declare any conflict of interest, which is the standard operating procedure of most medical journals that I've ever seen and most authors I've ever seen, you see no declaration there. Or if, for example, a study on coronary bypass grafting comes from the Cleveland Clinic or from the Mayo Clinic or some such, and they support the research and they make their money because of what's in this, but they don't declare a conflict of interest, is the mere fact of obviousness, the elephant in the room, shall we say, sufficient disclosure, or should we, medical journal editors, be requiring people to disclose, I make my money doing this, and it really matters to me what the results of these things are, whether or not it matters to you.
Understood. So it has to do with affiliation. I think Fee wants to.
Sorry, I don't know if I can help, George, but I'll do my best. Because I think you raise a really important point. It's not actually about this presentation, but that may not matter. I think the issue is, do people make more money by doing more of a thing? And certainly in systems like the UK, a lot of people are paid a set salary. They don't get paid more for doing more. In fact, they're often paid more for doing less. But in systems like, pay for performance, fee for service, you get paid more for doing more. So I absolutely agree with you, George. We need to be much more alert to clinical conflicts of interest that are to do with doctors' payments, and we've got to unpick that. I don't think it's been adequately done, and editors should begin to be more alert to that too.
Thanks, Tina. I'd like to come back to the presentation by Jory, and we have a question from Facebook. I think you partly addressed it in the later slide, so it may have come earlier, but just to verify, this question has to do with the likelihood, the differences in accepting invitation and then on submitting reviews once you've accepted invitations, and whether you can elaborate on both the acceptance rate difference between men and women, and whether this acceptance rate leads, whether there is any difference in delivering on the acceptance of invitation.
So whether the reviews actually complete.
So I think the first part of the question is whether there is a difference in accepting invitation, and I think you had data for that.
I think the difference would more be on the timing of whether that review is back in a reasonable time, and most people do complete the review if they do accept it. But they might need to be nudged a couple more times.
Right, but you don't.
But we didn't look into the timing of the reviews.
And I also want to say, I think it's fantastic that you actually did an intervention and that you showed some differences at the author submission. I think this is really encouraging for us all here, that we can actually raise awareness about unconscious biases. Did you see, I'm not sure, I may have missed this, but did you see that this then translated into more invitation and more reviewers that were female?
So there's a bit of a data lag between who authors suggest versus who editors. So there wasn't as much of a difference, and it wasn't significant because there's a time gap between when authors suggest and when the editors actually get around to inviting people. Right. So we didn't include that.
And do you remind your editors of this? Do you have a similar statement?
We don't have a similar statement, but AGU does work with their editors, and they're very aware.
One more question.
Hello, Karen Skaya. I'm at the American Academy of Neurology. I'm wondering if you looked at editorial board genders when weighed against reviewers, since I think journals look to their board members frequently to provide reviews.
So the editors do include the editorial board, and so because when there are more women editors, there are more invited female reviewers, because of women more closely representing the population that there is available. But we didn't look at whether on specific boards, when there are more women, does that affect the invitations that the men on that board suggest also. So we didn't do that sort of clumped analysis.
Hello, Michael Todd from Medell, Innsbruck, Austria. In my 5.5 years as a medical writer, I often find that the authors ask me who the reviewers should be. So how can you control, how do you know that the authors are the ones who are actually making the decisions for requested reviewers?
We wouldn't know.
Okay, thank you.
Annette?
Hi, Annette Flanagan, JAMA and the JAMA Network. Thank you all. I think I want to just state something obvious about this opening panel. What appears to me stellar early career women. I want to assure everyone that the decision makers were actually blind to the status of the presenters when this session was created, so thank you.
And if there are no other questions, I think this is a perfect note to end up with. So I would like you to join me in thanking all these wonderful early career women researchers. Thank you.
I hadn't noticed the gender thing, but be here back at 10:30. Is that right? Did I get that right, Annette?